Okay, let's talk about alkyl halides. They have the general formula RX. R, we talked before, is any hydrocarbon chain. X is a halogen like F, Cl, Br, or I, second last column of the periodic table. There have been some famous ones of these alkyl halides. C bonded to 3 Cl's and an H is its common name is chloroform. It used to be used as an anesthetic during surgery, but then they found out that it caused cancer, so they don't use it anymore. Carbon tetrachloride, 1 carbon, 4 chlorines. They use this as a solvent. Why? Because I know its shape is tetrahedral. It's therefore going to be nonpolar. So if you're trying to do chemical reactions and you don't want water to possibly become part of that chemical reaction because water is polar, you might flip over and try doing it in a nonpolar solvent, and they often used carbon tetrachloride as that solvent. Another big thing about these alkyl halides are CFCs. Yes, they're called chlorofluorocarbons, CFCs. And an prime example is a chlorine attached to, or a carbon attached to 2 chlorines and 2 fluorines. They call this guy freon. It's a refrigerant, which means it's being used in your fridge or your air conditioning units or your central air to help suck heat out of the air in your home and pump it out again. These things are very, very stable. They hang around for a long time, and eventually your fridge or your air conditioning gets broken. These gases escape. They get up into the air, and that is bad. Why? Because when they get up into the air, up in the upper atmosphere, there's a molecule called ozone. It's O3. Okay. And it does something very special. There's a whole layer of it up in our atmosphere, the ozone layer, and it helps absorb ultraviolet light. Ultraviolet light, which is high energy radiation, higher than normal light, and it would cause a lot of damage. Ultraviolet light causes skin cancer, for example. And so ozone absorbs this ultraviolet radiation. And so if we didn't have ozone around, we would be like this guy, sad. And these freon and other CFCs, when they're up there, they don't actually react with it in an ozone molecule individually. They act as a catalyst. Yes. They act as a catalyst. They turn O3 into, well, let's say 2 of them. They help turn them into 3 O2s. So they're getting rid of this stuff, and it's bad. And they collected at the South Pole, and there's a huge hole in the ozone layer. I think latest research says that it's starting to replenish itself, and these things are now not allowed. By law, if some person finds, or a business person finds this stuff in one of your refrigeration units, they're not allowed to repair it anymore, which is a good thing. Physical properties, they are going to be more polar than just a hydrocarbon chain. So the intermolecular forces here would go up, and so accordingly melting point, boiling point, solubility slightly would all go up. In terms of naming, if you have a fluorine, we use a fluoro group. Chlorine is a chloro group. Bromine is a bromo group. Iodine is an iodo group. So this molecule here, as I touched before, we're going to circle the longest chain, and I'm going to circle that guy. It's got 2 branches. It's got an ethyl group and an iodo group. Which one? Hopefully it's going to be obvious. This is going to be 1, 2, and 3. which one am I going to name first? It's still alphabetical order. Ethyl before iodo, so this is 3-ethyl, 2-iodo, pentane. And I will fix that up. That's good. And that's how I name them. They're named like any other branch, except I don't have an E on the end here. Other than that, it would be perfect. And that's how I name them. And that is a brief look at alkyl halides.